I'm Chris Siefert from Sandia. I'm talking about how we're doing Trilinos performance testing everywhere, insofar as the DOE definition of everywhere. So why did we start doing this? One of the goals here we had was to sort of take ownership of Trilinos performance, right? We don't want our applications people like poor Malachi to be surprised because we checked something into Trilinos that slowed his stuff down. We also want to make it easier to do an initial setup, right? So there's times when someone's like, oh, I don't know, something broke on this machine. And I'm like, I haven't built there ever before. So I email like the one guy and, a day and a half later, he gets back to me and he's like, use this configure. And it's great, but it's unfair to him. So we want to make that easier. We want to work with the Sandia application performance team on systems where they're active to stay up to date on the most recent good version of libraries. And this specifically matters with all the LCAP hardware because they're spending lots of quality time with AMD and encouraging the rapid evolution of the ROCm ecosystem. And various stages on that evolution are not something we want to use, and I don't want to try. And so working with APT to sort of identify, okay, you can move up now has been fruitful. It gives us a way to understand behavior across time and across different systems. And I showed you guys, if you saw my talk yesterday, a little bit of sort of really zoomed in version of that, which we can do, and it's kind of fun. And finally, it's provide a way for our app teams to know if it's safe for them to update Trilinos. I'd like to credit our team. Most of these folks are here. Most of them are actually in this room, with the exception of Tim Fuller, who was not able to make it. So what do I mean by everywhere? And this is my definition of everywhere. Asterisk, DOA everywhere. It includes CPU machines. It's Eclipse, which is an old CTS1 Broadwell machine. It's Amber, which is Sapphire Rapids DDR, that's CTS2. There's Tachi and Rocinante, which are both mini Crossroads machines. One's at Sandia and one's at Los Alamos. And we test them both to make sure they're performing the same. And I'll actually talk a little bit about that later. On the AMD side, we have Frontier at Oak Ridge. We have Tioga at Livermore, and we have RZ Adams and El Dorado, which are mini LCAPs. One's at Sandia, one's at Livermore. We have, in terms of our NVIDIA GPUs, we have Vortex. That's the old mini Sierra at Sandia. There's Perlmutter at NERSC, and there's Hops with H100s at Sandia. And then finally, Aurora itself on the Intel side. So our first piece of what we have is the Watcher performance system. So this is open source. It's developed as a Jenkins plugin by Elliott Ridgway. And I think that number is actually too small now. I think we're somewhere in excess of 40. We run a bunch of different tests on our relevant systems covering, ePetra for like another 2 months. But basically stuff inside Trilinos, Tpetra, Intrepid2, Mulu, Frosh, thanks to collaborations with Alexander Heinlein. And then we've got proxies for applications, Empire, Spark, Sierra SD, and Sierra Thermal Fluids. If your application's not here and you want to fix that, please talk to me. And so what we get for every test is something that looks like this. And this is a screenshot I took off Watcher. It's from May of last year. So I've got my raw data, and that's in blue. There's a running mean in red, and there's a mean plus a standard deviation in green. And so when the data looks nice, you're like, oh, we're coming along, and oh my gosh, something went wrong. And then, in fact, we can see kind of as the issue got resolved as we move forward in time. I had a great chat with the Chapel folks yesterday that they were actually annotating their version of this where the issue flagged and issue resolved. They're putting in explanations, and I think that's something I'd love to adopt in the future. So this is actually a success story of our performance monitoring system, and this has to do with Cocos. So if you saw Damien's briefing this morning, he talked about this. With Cocos 4.3, they changed the default behavior of Cocos serial. Someone somewhere decided, hey, I want to use Cocos serial inside of a threaded region. I have no idea what possessed him to do this, but the Cocos team, to my frustration, but probably quite rightly, decided, we should make Cocos safe rather than performant. But for Trilinos, where we don't use Cocos serial inside of a threaded region, it made everything slower. And that's exactly what you see here. In that particular example, it slowed fine element assembly down on CPUs by a lot. So we talked to the Cocos team about it. We saw this. We're like, oh, this is real. What's going on? And Christian Trott was very helpful here. We sort of identified this Cocos bypass enable atomics equal on. We immediately flipped all of our performance builds to use it to make sure it did what we thought it did. We emailed out our stakeholders to recommend they do likewise. And then some of our stakeholders had questions, and so we went back and forth with them. And the best part about this is none of the apps updated Trilinos in like that 10-day window we were debugging this. And so this was, other than having to add that to their build, this entire thing was transparent to them. We caught it before they could be shocked, and something that wouldn't impact their deliverables and milestones. One of the other success stories we have, and this is one of those capturing what you would hope to see sort of things. This is Frontier. So we started with ROCm 571, and then OLCF made a newer ROCm available, 613. It took us a while to get around to updating it, but we did, and this is a CG solve, and that's what happened. We sped up Trilinos by a factor of 2, moving to the newer version of ROCm. So good job, AMD. Improving your stack, but we're able to capture those sorts of effects that library changes have on Trilinos. And so as we update, we'll be able to have that data and we can share it with our sort of stakeholders and applications. So the next thing we did was say, okay, I have all these build scripts that I'm using, and this is Christian Glus's idea, and he deserves the credit for this. Can we disseminate these? So we've got, and this is internal to Sandia, we want to get the user facility configurations out on the open internet, and I think especially talking with Olga's benchmarking working group, I want to push this higher on our priority list. So Michael, we're going to have to talk, and Kurt, we're going to have to talk about how to get this out. But basically, we have all of our scripts that we use to do the performance builds. This will give folks a first step to start with, how do I build this myself? Then we have our daily stoplight chart. And so there's a bunch of different sort of colored dots here, and I'll walk you through it, right? So you've got all the machines here horizontally, and then different categories of tests. So Trilinos packages, applications, or whatever. We see a couple dots. We see the did it run at all dot. That's mostly for us. That's a, did the system go down for DST? Did cron get wiped? Did the Jenkins runner fail, right? Did GitLab break, right? Any of those things can happen, and they do happen. And so that's our first look of, did we stop getting results for whatever reason? Then you get a second light, which is that 4 out of 4. It's, did the test stop running, right? The tests that have been running for the last month, are we still seeing all of them, right? Or did a test suddenly start crashing because someone checked something into the code that broke it? Or the TPL's update that broke it? And the last one is basically a one-shot, a little bit on looking at performance. So this is a single agglomerated statistic from all the Jenkins stuff. From the performance team perspective, we don't look at that data all that often. That's not for us. That's for our app teams to get a quick look as like, hey, are we expecting, if I were Empire and looking at mini EM, I would want to see those are all green before I think about updating Trilinos. And this was Michael Wolf's idea, so I want to definitely credit him on that. The next thing we have is our weekly Cocos kernel develop integration report. So each of these guys on the bottom represents a different test. I remove the names because it doesn't matter for the purpose of this plot. And what we have here is you've got your little kind of error bar representing Trilinos with the last release of Cocos. So basically, if you clone Trilinos off GitHub, that's what you get. Then we do the same thing, but we use VOTD, Cocos, and Cocos kernels. And then we get the little line. Now, granted, right, you're never going to see it all perfectly within, right, statistics. You expect a couple of them to be out, but not by a whole heck of a lot. And this looks pretty good. You're like, this guy, maybe, but that's like 5%. So that there's a real chance that's noise. You want to check it again next week for sure. So I get this every Tuesday, and this also goes to Nathan Ellingwood on the Cocos kernels team to give them an advance warning of, hey, you guys might have broken Trilinos. Please take a look here. Trilinos, like lamps, are two of the important smoke tests for Cocos and Cocos kernels. We tend to break it frequently, and so giving them early warning of that earlier in the development phase and integration makes everyone's life easier. And then finally, we can do our cross-system comparisons. I showed some of this yesterday, but here's an example on the CPU side. So this is everything is normalized to Amber, that's Sapphire Rapids with DDR. And then you have Eclipse, Rocinante, and Tachi, which are both the mini Crossroads machines. You can see if I'm at 25 ranks in this example, they're the same speed. Like all my fancy DDR buys me nothing. Fantastic. Once I get to 81 or 100 ranks, now that fancy HBM, sorry, HBM, not DDR, that fancy HBM is now buying me almost a factor of 2 improved performance. And more importantly, the two machines that are supposed to be the same are the same or pretty darn close to it. So this gives us confidence that our admins haven't screwed anything up or gotten out of sync with Los Alamos in any wonky way. We can do the same thing for GPUs. These are some comparison results we see with Vortex and Hops, which are two NVIDIA machines, and then Frontier and Eldorado. And you looked at that and you're like, huh? Why is the MI300 machine so slow? It should be faster than Frontier. This is weird. What's going on here? And so we actually had certain tests that were 4 times slower than you think they should be. And that's something we only picked up because we were looking, kind of comparing across machines. And so we called up our friends on APT, James Elliott, and we worked to identify the issue. And it turns out the issue was the file system, which is not something I would have guessed in a million years. But basically, if you have a test that's short and a binary that's large, you know, when you start running the binary, it starts pulling this off disk. And if the file system is slow, it's going to pull it off disk slowly. And it's running while it's doing this, right? So what I wound up measuring was not how long it takes me to multiply a matrix. What I wound up measuring was how long does it take me to get that binary off the disk? And it turns out if I ran it a second time, everything got faster and got me the performance I expected, right? 4x faster. Well, that's great. So we worked out a non-Trilinos reproducer where you just get a gigabyte long text string and compile it into a binary and then run it. And you can see the performance difference between first and second run really clearly. It's also not unique to Eldorado. When we flip the switch to run everything twice and keep the second timing, the timing on several other machines also sped up. Now, we could have tried to find machine-specific like RAM disks or fast local storage. That's another option. And probably if you're running for real, you might want to do that. But this gave us a fast way to sort of turn this on across the board and get more believable timings. And now on our LCAP hardware, we get results consistent with what we should expect, which is pretty cool. So, you know, what have we done? We've provided a maintained means for dissemination of good Trilinos configurations. So for folks who want to start on a system for the first time or have it in 6 months, they have a place where they can go. You know, Roger will email me, how do I? And I send him the link, you know, and he's got a place to start. There's no guarantee we enable all the right packages for his use case, but at least gives them a place to go and gives them the right modules to get set up. We review all the results weekly. We have a Tuesday meeting, and then we also provide our weekly emails to the Cocos and Cocos kernels team, and then handle questions from Nathan Ellingwood, like, hey, what's going on with this thing? You know, what do you guys think? And we iterate with that. And if we need to invite Nathan to our team meeting to discuss in detail, we do that. We've got cross-system comparisons to provide feedbacks both to the apps and admins. The Eldorado people want me to try like their new fancy disk now to see if we could improve performance. So that's on my to-do list. And where do we want to go with this? I want the user facility configurations on the internet. I want to get these on GitHub for folks who are using NERSC or ALCF or OLCF. I want them to be able to start with what we've got. We're also working with the Sandia admins to automatically identify and flag system issues. So like thermal throttling is the one that I can easily get in my head. Right, if the CPU slowed down for some reason, I want to see my little performance thing with an asterisk on it. So some of the LDMS team at Sandia that does a lot of the machine monitoring is working at trying to get something we can use with that. So we've been emailing back and forth, and they've had a conference deadline recently, so they've been kind of busy on other things. But hopefully when I get back, we'll hear more from them. We'd like to get proxies for more Trilinos applications. I talked to Vin last week, and we're hoping to get something for the Adelis software, which is used by Sandia's Gemma application. And then if we have more DOE-relevant systems, which there's not a whole lot on the queue for this year, but eventually NERSC 10 will show up, right? And we'd like to be able to do those as well. So thank you all very much for your time, and I'd be happy to take any questions. Yeah.
So you monitor Cocos develop. How often do you see that break?
It happened a lot more frequently before we started looking, which is what kind of triggered this. We had a couple of Cocos promotions in a row where something went wrong, and then I'm like, okay, can we do better? And things have been actually pretty good ever since. There were some questions that things were kind of borderline with prep for the most recent Cocos release that Nathan and I looked into, and we agreed that it wasn't an issue, but you know, we wanted to be sure beforehand.
I noticed that your timing seems to be rather linear, in the sense that you seem to be timing whole execution instead of anything more detailed.
That's just what I showed you. All of our timers are nested. And so I can drill in as deep as I want. Right? I need something that I can quickly look at with my eyeball over 40 odd tests. But sometimes something spikes. And like the example I showed you with Amber, we can go like 7 or 8 levels down to try to figure out exactly what went wrong. And so that's usually something we never look at unless we see a macro issue. But that we're not perfect about it. There are lots of things when you're like, oh, something went wrong. Can we add more detailed timing? But we try to have that for when we need it. Martin?
Oh, yeah, I just wanted to mention that in Tpetra, you guys also have tests that count how many fences happen.
Yes.
So those are also a bit annoying for this. They are really good. They really allow probes and bugs to be avoided.
Yeah, so we
Adding to the specification.
those are actually, yeah, that's a good point. That's part of our CI. This is mostly a trap for the Cocos and Cocos kernels team to, an acceptance test, if you would, where we basically make sure that, hey, you guys fence or not fence during certain behaviors. We want to make sure you keep that up. And we actually caught a problem at that point. With the Cocos promotion, Nathan was like, hey, why is this test failing? I'm like, we looked at it and like, someone added fences to SpimV in Cocos kernels. How did that happen? Can we not have that? And the Cocos kernels team identified it and quickly fixed it, right? So they were able to be really responsive. And that's, we're all part of the same team, and the ability to give them that feedback sooner rather than later, I think works pretty well. Okay.